Okay, so I'm going to start off with a slightly controversial point, or not slightly controversial, but this is Bingham Canyon just outside Salt Lake City, and I've got the title there, Mining is Old, Dirty, Problematic, and We Don't Need It, right? I mean, I hope nobody in this room thinks this right now, and if you think it right now, you won't think it by the end of this presentation. But the fact is, there's an awful lot of people outside of this room in Europe, in North America, South America, across the entire world who think that we don't really need mining anymore. However, mining has been and remains vital to modern life and society for centuries. It's going to remain so for the foreseeable future. It's becoming more and more important. I'm sure you've all heard about critical metals, critical minerals, critical raw materials, critical whatever you want to call them. The fact is that mining is probably more relevant and more spoken about now than it has been for decades. But even now, people don't really think about mining, where things come from, what we need to actually develop a mine, and so on. That phrase, mining is dirty, harms the environment and people, that may have been the case in the past. Mining companies do a better, not perfect job of environmental assessment, cleanup, etc., and I'll talk about some of those things later on. They're certainly more socially aware. They have to be all of these things, because if they don't get things right these days, they don't get the permission to operate or license to operate, depending on what terminology you want to use. Perhaps more importantly, if you want to do anything about climate change mitigation, limiting carbon dioxide emissions, that's going to require more mining than we're doing right now. We already mine more right now than we ever have done at any other point in human history. And the situation is especially critical, and that's a kind of pun, for metals and minerals with insecure supply chains that are critical for manufacturing, defense, high technology industries, and climate change mitigation. But before we get into all of this, I just want to start off with a brief reminder of why modern society needs mining. So this is a figure produced by the Minerals Education Coalition in the US, and I've put some civilized units on there for those of you who don't use pounds and things like this. I certainly still don't after 10 years in the US. But the fact is, every American is going to need about 3 million pounds of minerals, so you're talking about 5 tons of clays. Still quite a lot of coal, although that number's decreasing. Quite a lot of lithium, that number's increasing. Quite a lot of salt, phosphates, you name it. Basically, we mine it, we use it in ever-increasing numbers, with the exception of certain commodities like coal, which is on a global basis is getting hopefully close to a plateau. One of the reasons we use more and more of the periodic table, one of the reasons we mine more and more of the periodic table, is that in the last 20 or 30 years, we've gone from the technology on the left to the technology on the right, which everybody has in their pocket or on the table in front of them. The colors on the left there indicate the amount of, or the different commodities, the different metals, the different elements we have in the technology that we were using in the 1980s. On the right there, we have a modern smartphone. We've basically doubled the amount of elements we put into things that we consider routine. I mean, everybody wants smart technology, but that smart technology comes at a cost, and that cost is effectively having to mine more and more of the periodic table, because if you can't grow it, you have to mine it, and that's still very much the case. If we get into details, I'm sure you've seen diagrams of this like this before. This is a little maybe small for you to read at the back, but if anybody wants a copy of this afterwards, I'll happily provide it as a PDF. But basically, you name it, we've got it in the smartphone. We've got copper for wiring as well as silver and gold. We've got rare earth elements for those little haptic touches, vibrations, the little magnets you need for those in the smartphone. If you want a touch screen, you need a thin layer of tin indium oxide, and there's all sorts of other things like lithium-ion batteries and so on. If we think about green technology, this is an example of a wind turbine. The numbers are approximate. They vary by the capacity on that wind turbine, but you're talking about a lot of aluminium, a lot of rare earth elements, a lot of concrete, a lot of steel, a lot of copper, some zinc, some moly. If we look at things like solar panels, depending on the technology, you might be talking cadmium telluride, or you might be talking things like molybdenum, beryllium, germanium, gallium, silicon. You've got to have a lot of copper to stick all of this stuff together to make sure the electricity we generate from these solar panels goes somewhere. And you've got frames that contain aluminium, titanium, zinc, magnesium, and so on. All of this means over the last 50, 60 years, we've basically ended up with a scenario like this. This is a complex diagram, but what I want you to take away from is the overall trend that all these lines have, with the exception of one that I'll talk about shortly. This shows primary mined production from the 1950s to about 2022 in this case, although I've got some updated numbers there on the left for basically, you name it, the mined commodity of your choice. You can pick whichever one you look at. You can look at the trends there. The fact is that everything is going up to the right with the exception of arsenic, and that's because we use less arsenic now than we did in the 1950s because we changed the way we use arsenic. Some of the numbers there on the left, we mined seven times more copper now than we did in the 1950s, nearly 50 times more gallium than we did in the 70s, nearly 40 times more lithium than we did in the 1990s, 14 times more nickel, 75 times more rare earths, and about 4 times more zinc. You could say, oh, well, that's due to population increases, so why don't we just normalize this to a per capita basis, divide these numbers by the population increase since the 50s, and lo and behold, we still get an increase. With the exception of tin, arsenic, as it was before, lead and tungsten, everything else is still going up to the right. Everything else is going up to the right in certain cases significantly. So every human on this planet right now uses 2.5 times more copper, mined copper each year than they did in the 1950s. And copper is one of the metals we're actually pretty good at recycling. Gallium, 23 times, lithium, 27 times, nickel, 5 times, rare earths, 26 times. So everybody in this room is using 26 more times rare earths, primary mined rare earths than they did in the 50s. One of the reasons for this is stuff like this. On the top there, we have electric vehicles and the range of commodities you need for an electric vehicle compared to a conventional petrol or diesel vehicle. And then we have power generation, so offshore wind, onshore wind, solar photovoltaic, nuclear, coal, and natural gas. So if you want more renewable energy, if you want an electric vehicle connected to that renewable energy, the fact is everything that we want in those cases is more mineral intensive than the technology we've been using or that we're replacing that we've been using for the last few decades. I've got a few examples of this. This is close to home. This is the Sparks Gigafactory. It's a Panasonic Tesla lithium-ion battery manufacturing facility. It's just outside Reno, Nevada. It's got a capacity of 35 gigawatt hours of lithium-ion battery cells per year. If you do the maths and actually look at and think that this facility is making what's called NMC 811 batteries. This isn't a battery conference. I'm not going to go into the details, but NMC 811 just means you've got a cathode in there that contains 80% nickel, 10% manganese, 10% cobalt. If you do the maths, and if this thing's running at full capacity, you're talking about 4,000 tons of lithium a year, 3,000 tons of cobalt, 26,000 tons of nickel, 3,000 tons of manganese, and an awful lot of graphite, as well as aluminum and other metals. This facility could use about 1.6% of total global lithium production, 0.7% nickel production, 1% cobalt production. There's 300 of these in development, completed, underway, or planned globally, because we know we're going to need an awful lot of lithium-ion batteries over the next few years. I bet you everybody in this room has a lithium-ion battery in their pocket or on the table in front of them right now. Some of you might have even driven here using a lithium-ion battery. If we look at other metals, this is basically comparing the amount of copper in electric vehicles. So at the top there, we've got a normal vehicle with 21.7 kilos of copper. On the bottom there, we've got a fully battery-powered electric vehicle with 83 kilograms of copper. If we do some back-of-the-envelope maths, global vehicle production, these numbers are updated to the latest numbers I could get. So in 2023, global vehicle production of all types used 3 million tons of copper. That's about 13% of global copper production. 20% of these new vehicles in 2024 were electric. That 3.5 million electric vehicles sold in 2024, that increase of 3.5 million vehicles is more than the total number of electric cars sold worldwide in 2020. So this just shows the acceleration of this market and the metals we're going to need to actually meet this demand. There's a whole lot of targets for various countries to move to all-electric vehicle fleets. I'm living in the US right now. We're not thinking about going all-electric for various reasons, as you might have heard, but there are still targets globally for a lot of countries to move to all-electric vehicle fleets. Battery electric vehicles use about 4 times as much more copper as a petrol vehicle. If we go all electric, the global car industry is going to need about 7.5 million tons of copper a year. That's assuming no new growth in vehicle demand. That's a 150% increase from now. That's about 33% of current global copper production going into vehicles. You've got to connect those electric vehicles to the grid. You've got to upgrade the grid. You've got to actually connect the renewable energy you want to power these vehicles to those vehicles. There's all sorts of things we need to think about. This is just transport. There's all sorts of other things we need to think about. Data centers. I'm sure everybody's having conversations about data centers right now. Are you guys having in Europe talking about data centers, yes or no? Is anybody going to answer me? Yes, thank you. The fact is that these data centers are happening already. I heard recently that Caterpillar, the construction vehicle company, one of the main things they're being asked about is what construction vehicles can you provide, or how can we actually generate all these data centers? Because there's a demand for them that's increasing rapidly, but we're still working out how to build them. More importantly, we're still working out what the mineral and metal cost of data centers is going to be. And this on the left is estimates going from 2020 to 2040 for the amount of copper that's going to go into data centers in the US alone. So that's it's 193,000 tons of copper a year going into data centers by 2040. And this is why 75% of that copper is used in power distribution, then grounding, plumbing and HVAC and so on. And this is, again, just the US. These data centers are being rolled out globally, and they're going to have a significant impact. So the details here are probably a bit small, but the fact is what we've got there is electric vehicles at the top, data centers in the middle, electrical transmission and distribution. The thing on the right is the list of elements: lithium, rare earths, copper, gallium, germanium, gold, nickel, silicon, iron, lead, and so on. All of these technological advances that we are going through right now needs lots and lots of metal, and that lots and lots of metal is only going to come from one place, and that's mining. And this is one of the things that we're thinking about in terms of where we're going to get that metal from. This is looking at global demand and supply balances for key commodities in 2035. Anything with that kind of greenish color at the top means we're likely to be in deficit, so we need to find more of it. So that's lithium, copper, rare earths, nickel, zinc, graphite, tin, aluminum. There's a lot of commodities that we're likely to be running short of if demand scenarios based on what we're going through right now are viable, essentially. So that's the kind of challenge. Those lines I showed you at the beginning, that with all those commodities going up to the right, that's the baseline. And what we're seeing is that baseline accelerating for a range of commodities because of the way we're essentially living, what we want as a society, whether it's artificial intelligence or electric vehicles, is changing. And every change we want, every change that society is demanding, or that companies are telling us that we want, has a metal and mineral cost that we need to meet by mining. People do talk about recycling, and recycling is a great idea. We already recycle a lot, but the fact is not all metals can be recycled. There's a whole load of barriers to recycling. We lose things by design. There's technological and logistical barriers. Who here has an old smartphone or an old laptop or an old iPad or something like that sitting at home in a drawer? Stick your hand up. You guys are the problem. Seriously, you have essentially rare earths, you have lithium, you have all these commodities we want, and yet we don't know what to do with them because the recycling chains have not been developed. So the fact is that with recycling, mining is important, but we can't just mine stuff for it to be one use only. We need to actually make sure that the increase in metal and minerals we're going to be introducing to society can actually be recycled at their end of life. There's going to be hundreds of thousands or millions of Teslas and other electric vehicles coming to end of life in 5 to 10 years. What are we going to do with them all? We're going to put them on landfills. We're going to take them to scrap heaps. They're all going to have lithium-ion batteries, and we don't want those lithium-ion batteries to catch fire and cause all sorts of problems. So we need to think about this stuff right now. We aren't at the stage where demand can be met by recycling because of things like this. So this looks at essentially the amount of spent batteries from 2020 through to 2040 and the recycled and reused volume of certain metals. The fact is the recycling potential is going to be huge over the next decade or two because we're putting more metals and minerals into the economy. So we need to think about how we can actually make that economy fully circular, like I know you've heard a lot of. But this is a big challenge because these are slightly old data, but they pretty much hold true still. These are recycling rates of a variety of different metals and minerals, a variety of different elements. The fact is, the ones in blue, we're pretty good at recycling, so precious and base metals. The ones in red, they're all the critical minerals. They're all the critical metals, minerals, critical raw materials, and to be honest, we're pretty rubbish at recycling them. And these numbers haven't changed much. This is 2021 estimates. Notice they're less than 1% lithium and the rare earths. So there's a huge amount of talk about how we're going to need more lithium and rare earths, but the fact is at the moment we're treating them like one-use commodities because we're not recycling them. And that's something we need to think about in terms of how we as a society are going to ensure that the metals and minerals we're actually mining out of the ground are not, as I say, just one use. We need to make sure that we think about what we're doing with things as they come to end of life. So that's the challenge we as a society, we especially as geoscientists face. What we need to do is we need to mine more, we need to discover more mineralization, we need to more sustainably and better use the mineralization we know about. In other words, not just produce a main commodity, but produce as many commodities from a mining operation as we can. We need to make the most of these non-renewable resources, and all of this needs research, workforce, and much more. Everybody in this room has the potential to contribute to this in one way or another, and I think that's one of the reasons why I might have been asked here to talk today. But the fact is, if we don't succeed, what we're going to see is demand for metals critical for low and zero carbon dioxide technology, or indeed all metals, is going to exceed supply. Increased prices will go up for things we use in everyday life. There's recent price issues over all sorts of supply chains we've heard about. Oil is a good example right now, but the fact is if we continue down this path where we're going to demand more and more metal and we don't have the things in place to meet that demand, you could hear that same scenario occurring for anything on the periodic table that we have to mine. Worryingly, if we keep on moving in this direction, if we don't meet this demand for metals and minerals, we could see slowing of climate change mitigation, competition from production for different sectors of the economy. All of these scenarios are not good. However, I'm not advocating we mine everything everywhere. If we misuse resources by just driving up production at the cost of everything else, that means we'll actually misuse things like water, land, air, will create social problems, and that's not a good scenario either. We need to find a kind of happy medium where we can actually mine responsibly, the minerals industry can operate responsibly, and while meeting the increased demand for metals and minerals we see as a society. There are going to be environmental and social challenges, potential conflict between governments and so on. All of these are not good, but that's why we need broad and holistic approaches to economic, mineral and metal deposit geology, geometallurgy, mineral economics, policy-focused research, and broader discussions. All of these things need to be basically front and center, and that means the geosciences globally should be at the front and center of everybody's mind, because we are a crucial part of resolving these challenges we have as facing us as a society. We also need people, and this comes back to the kind of second half of my talk. I talked about the fact that who needs mining. Everybody in this room needs mining. Basically everybody globally, almost everybody needs mining. Who does mining need? What we need, if we're going to succeed in meeting the mineral and metal demands of the future 10, 20, 30 years, is essentially a successful, legitimate, and socially and environmentally responsible mining industry. That's going to need a huge range of different people with a lot of different skills, but also with the right mindset. Not mine everything everywhere and be damned with the cost. People close to mineral mining projects may be excited at opportunities, but they also have a lot of concerns. What's a mine going to look like if it happens? Is there going to be work, schools and training? What are the environmental risks? What about agriculture and fishing challenges? Will our way of life be disrupted by incomers, resource curse or resource benefit, and much more? And that means that the minerals industry needs people who are not only interested in geoscience as a research topic, but also those fundamental questions about the role of mining in society and the importance or the challenges or the social and environmental costs or benefits that the minerals industry brings. We need to actually talk about things like mutual benefit. You need to be able to, as a geoscientist, anybody in this room should be thinking about this anyway, but you need to be able to explain your own science and other findings in straightforward ways. You need to listen openly and be honest about the implications of your research. We need to collectively think about how we can mine with lower impact, less footprint, maybe even use mining waste as feedstock, as we've heard about potentially some of the talks and posters at this conference. We need to agree on how we can monitor industry and actually get industry to publish indicators on how they're doing in terms of sustainability. And we need to think about things after mining decades down the track. So the fact is that the minerals industry doesn't just need geoscientists like these people, like everybody in this room, but those geoscientists need to think that mining has a truly important and integral part of, all of these things here are an important part of the industry, not just finding stuff and digging it out of the ground. In terms of specifics, who does mining need? I'm going to take one example, and I've taken I'll show it on the next slide, but one of my friends who works at SRK Consulting provided me with this list of people who are involved in just one aspect of the minerals industry. So if we look at remediation and environmental and socially responsible closure of mining sites, the list of people here, and you might be able to find yourself on that list somewhere, is what you need to actually effectively close a single mining operation at end of life, or deal with a legacy mine site. So geologists, geochemists, hydrogeologists, botanists, biologists, climate change specialists, land use planners, GIS specialists, it's a long list, and that's just one aspect of the minerals industry. If you think about mineral exploration, what's needed there is not just geologists, not just geophysicists, not just geochemists, but also all of those people who know how to interact with people. If you do mineral exploration, you're often the first people on the ground, and if you mess up that impression, that's not a good thing. There is a disconnect, though. We know that modern society, modern standards of living, as I've mentioned, require more metals and minerals than at any other point in our society. Situation is only going to increase, as I've mentioned, because of the energy transition, because of societal demands, because of increasing global standards of living, and so on. The fact is that modern society is disconnected, more disconnected from the minerals industry and primary industries where we get metals and minerals from than was previously the case, certainly than probably has been the case for the last few decades. That means that, as I've mentioned in that second slide, mining is thought of as irrelevant, old-fashioned, problematic, and it's not needed. And that means that people don't really want to go into the mining industry. We're going to need more and more people with the right mindset and skills, but people, young people like those in this room, probably don't think about mining as a viable career. That means we essentially have this compounded workforce problems where if we want to mine more minerals and metals for modern standards of living and climate change mitigation, we're going to need more skilled and passionate people. But in a lot of countries, we're seeing the opposite trend of enrollments in geoscience classes decreasing and so on. And what we need to do basically is need to engage better to avoid the following. We've got this slide I showed on my second slide saying mining is old, dirty, problematic, and we don't need it anymore. The fact is that, a lot of people, if you basically talk about mining, they envisage a great big hole in the ground that's full of problems without any benefits coming out of it. And yet, if I say the word farming to people in this room, you probably have a vision of something like this. You might hear some cows mooing in the background, maybe a nice, some birds chirping. It's a nice scene, right? We can connect with farming. We know the importance of farming in our everyday life, but we can do that without considering the negative aspects of farming, like biodiversity loss, nitrate and phosphate runoff, carbon dioxide emissions, factory farming processes, all of these things that happen with farming that we conveniently put to one side because we know how to connect with it. We don't do that with mining. We focus on the negative. With farming, we tend to focus on the positives and ignore the negatives. I'm not saying we should all target the farming industry and have a go at farmers, but the fact is we can all connect with this far better than we can with the minerals industry. That's one of the challenges. The other challenge is things like this. This is looking at student enrollment in earth science, Canada, Australia, the US, the UK. What we've seen, and these trends continue, the fact is that earth science enrollments are globally, certainly in most countries, decreasing at a time when geology is more scientifically and socially relevant than probably any time in the last 5 or 6 decades. It's not just earth science, it's also mining engineering. So this is mining engineering in Australia and the US. Right now, we need more mining engineers as well as geoscientists, and yet we're not getting them because people can't see a viable or don't understand the relevance or importance of the minerals industry and certainly can't think of careers. And so that's what's happening in terms of the pipeline, the workforce pipeline, if you like, and this is what's happening in terms of what we need. This is one example from Australia where mining employment, that trend continues on to the present day and it's at a record high. So what we have is a situation where we have people who don't know that mining is a viable career option, don't know the importance of earth science, don't want to go to university to do geology at a time when they're needed most. And it's not just, that's Australia. I've got a few other examples here. These are all labor demand risks. So 2030, the Canadian minerals industry is going to need about 80,000 to 120,000 people. Similarly, in the US, we're going to need an awful lot more people. In South America, in Australia, if the mining industry ramps up here in Europe, you're going to face the same situation. So we have a dichotomy where we have all these people who don't know that the minerals industry is a viable career option, who aren't interested in the earth sciences because they don't get taught about it at high school, but this is the time when they're most needed. So we need to think about how we can actually change this scenario and actually get people to think about the minerals industry and the broader geosciences, earth sciences as a viable trajectory to a fruitful career. But this is the scenario we're dealing with on the left. That's that mining engineering graduates, a graph that I've shown already. On the right, this is a survey of people ages 15 to 30 and where they would consider working. That dark 42% at the top for the mining industry is people who would definitely not work in the minerals sector. So we are at the moment, we're at the top there. Oil and gas is next, and a lot of people think oil and gas is worse than mining, and yet oil and gas is more attractive as a viable career option. So we need to rethink how we engage with people, and we need to rethink about maybe how the minerals industry thinks about itself. So the minerals industry, obviously, it's an industry. One of the main drivers of industry is that bottom right circle there. Is this a laser pointer? Yes, it is. This bottom right circle here where, everybody in the minerals industry thinks about this economic value. That's things like profit, return on investment, and so on. To actually engage better and to be generally a better part of society, the minerals industry should also think about environmental and social value forms. In other words, demonstrate value beyond profit to communities you work with, think about potential positive environmental impact, move towards things like carbon neutral mining and so on to actually negate or lessen the impact of mining activities. What we're talking about here is how the minerals industry needs to think to move towards longer term sustainability and demonstrate that effectively to actually engage better with people who might eventually want to go into the minerals industry. We need to demonstrate these values in an honest and legitimate way, and that can only help with workforce challenges. If we just think about profit and mining everything everywhere, then that's not going to get a whole lot of people on our side and do the things that we need to do for effective climate change mitigation and so on. We need to think about what young people want. So, salary is one thing, but, these are things like looking at Generation Z or Z, and millennials, and the fact is, good work-life balance, learning and development opportunities, then salary, then positive workplace, derived sense of meaning for my work. All of these things you can potentially apply to the minerals industry if the minerals industry can actually put these things at the forefront of their workforce considerations. On the right there, basically Gen Zs and millennials thinking about what sectors they may well leave. Energy and mining is up there. 46% of people working in that who are the Gen Z generation are thinking about leaving, 34% of millennials. So it is about retention as well, and this is all things that I have been speaking to the minerals industry about, but the fact is they need to think more about it. And we need to understand what people value. Salary is great, but there's a whole load of things, compensation is important, but things like meaningful work, workplace flexibility, career development, and so on. All of these things could be part and should be part of the minerals industry, and if they were part of the minerals industry and we could get that message out without greenwashing or using propaganda, then I think we would have a better chance of actually attracting people to mining. And primarily because mining is crucial to society, as crucial as farming in many ways. So what can we do? Basically, we need to connect better to younger people, ideally before high school. Geology is typically not taught in high school or school at all, apart from maybe as a bit of geography. So we need to actually connect better with people and then outline the importance of earth science. We need to have open conversations about the importance of mining within modern society, modern life, climate change mitigation, but we can't go too far and greenwash and say we need everything everywhere to be mined and damn the consequences, because that'll just alienate people, and it's us putting, or the minerals industry, putting profit above everything else. We need to think about what the work priorities are of young people. And maybe this is something the SGA can think about in terms of career development, workforce development. What do you all want out of a career other than a good salary? You know, what, for example, is turning you on or turning you off about potentially working for the minerals industry? Do you realize there's opportunities in the minerals industry and you're part of geoscience? There's all these things we need to talk about, and we need to talk about them in an honest and open way and say that there are some good companies out there doing some good work. These are the companies you probably want to work for, because you'll tick a lot of the boxes in terms of what you want from a career. We need to demonstrate that the minerals industry has problems, like most industries, but that things are improving. There's a whole load of sustainability reports you can look at for major and minor mining companies that actually demonstrate and talk about what they're doing in terms of sustainability. But equally, the concept of change from within is crucial in any sector. If you want to change something, one of the ways you can do it is become part of it and then change it from within. And everybody in this room is a potential leader in whatever industry you want to go into. So if you're thinking about going into industry and there's certain aspects you don't like about that industry, I would emphasize you've got a greater opportunity of changing it once you're in that industry than trying to change it from outside. And we need to remember what's important for young people and for retention of the existing mining workforce. There's huge opportunities for work relating to the minerals industry. We need to attract and retain the right people, and I'm pretty sure there's a whole lot of those right people sat in this room right now if they're interested in moving towards the minerals industry. So I'm wrapping up. Probably got a bit of time for questions for sure. But the fact is the minerals industry is facing some of its greatest challenges and opportunities as a result of changes in society and the energy transition. One of these key challenges is workforce and capacity building. We had a national academies meeting in the US actually discussing how we build capacity for minerals resources workforce in the US. And there's lots and lots of conversations happening like this globally. But the fact is we need to connect people to the minerals industry. We need to talk about potential career and other opportunities. We need to talk about the importance of the work for society and for climate change mitigation. And we need to do this in an open and honest way. Everybody in this room should know that we all need mining. Everybody in this room should also know that if they wanted to, they could have a role in the minerals industry, and that role would be positive in a number of ways, not just a paycheck at the end of the day. And if we want workforce, the minerals industry, people like me need to engage with young people who often have different interests to just good pay, are concerned about the negative impact of mining, and talk about things like change from within. It's all right saying the minerals industry is really important and will get you a good paycheck, but most people, certainly in this room, most people outside of this room want much more of that out of a career. And that's all I've got, I think. If anybody's got any questions, I'll happily answer them now. If anybody wants a copy of this, I have papers as well, resources. Happy to continue this discussion via email, via any medium you want, over a Pivo later on today. I've learned one word of Czech, maybe. But certainly, thank you for the opportunity to speak to you all, and I'll happily answer any questions anybody has. Thank you.
Pivo is very important. Thank you for your presentation. It was excellent. I'm happy that I can open the discussion. So,
Thank you, Simon, for a very nice call. It really surprised me as you mentioned that only 1% of the methane, more than 1% is recycled. because I know that the gravel drains, they actually recycle them. So they recycle them because of all the metals like you mentioned, cobalt, copper and stuff, and they don't recycle the rest of the landfill. Is it because the lithium chemistry of the batteries complex and or it varies between various ones?
So I think globally we're moving to recycle those batteries. We're still pretty poor. If you look at the areas, there's certain countries where you can go and you can see basically scrap yards full of electric vehicles that are not actively being recycled. They're just being dumped and because people don't know what to do with them because they don't have that recycling chain. We're making some moves in Nevada because we have that battery manufacturing facility, and nearly next door, we actually have a lithium-ion battery recycling facility. So they're basically taking the lithium-ion batteries, they're crushing them up, they're turning them into what's called essentially black mass, which is the ingredients for a lithium-ion battery, and they're starting to put that back in. But there's a couple of challenges. One is that not many electric vehicles are coming to their end of life right now. So there's not a huge amount of feedstock to go into that recycling. So we're putting an awful lot of lithium into electric vehicles right now, but that lithium will not be available for recycling for another decade at least. So that's one of the things that's why that 1% is like that. It's because we're still mining and putting into lithium-ion batteries far more lithium than we're actually than is actually available for recycling. The second part of it is that there's a whole lot of other lithium-ion batteries that are much smaller but much more common that we still are not very good at recycling. Hence my asking who has an old laptop in their house somewhere. And that's one of the reasons they're not being recycled is because we don't know what to do with them. There's no production line to get that stuff into a recyclable state. It's not, the challenges are not technological in many cases, it's logistical. So, and I think the reason why we're not recycling much right now is because there's not a huge amount available to recycle compared to production, but that can and will change. But the question is, do we have the recycling capacity to increase that 1% when all those Teslas, electric, Ford, Mustangs, you name it, when they all come to end of life, are we prepared to deal with that and to make sure that that lithium, that cobalt, that nickel, that phosphate, whatever it is not one use?
Thank you very much.
Thank you, Simon, for the talk. I will continue with the recycling. You showed a periodic table that for some percent that is recycled or recyclable?
That's recycled. I cut out a diagram that shows recycling potential because I didn't realize I had. If you email me, I can send you a paper that outlines a recycling potential because a lot of the elements we use, including the rare earth elements, are eminently recyclable. But the fact is, there's dissipative use where you put phosphate on a field and you'll never be able to recycle it. But a lot of the uses we have for an awful range of the materials we mine, those uses are recyclable or will be recyclable in the near future. But the fact is, we're just not doing it.
Okay, and are there any limits to the metals, rare earth elements, or some other metals that when you recycle it, it loses some of its aspects or characteristics, so it will not be usable as it was before it was fresh?
In most cases, no. There's some challenges over the composition of the things you make, or the way you might use like rare earths and things like this. But if you think about aluminium or copper wiring or aluminium foil or aluminium metal, those things are nearly 100% recyclable. The rare earth element magnets and the neodymium magnets, they're really recyclable as well. So there's a lot of things that we could be doing more of, and there's significant potential to ramp up, but we're not there yet because we haven't made the investment in recycling in a large number of areas, and then it comes down to the carrot isn't working, so maybe we need to use the stick and actually legislate to enforce people to recycle, like you've done in Europe. But I will say that legislation in Europe probably won't work in the US for one or two different reasons.
That's true. So we are not doing it yet.
Not doing it yet. There's huge potential, but we're not there. And that's why we need to think about it. Maybe I should have given a recycling talk.
I have a question regarding lithium. Do you know if there are any promising alternatives regarding this element when it comes to the electric means that we use nowadays?
Sorry, could you say that again?
So we use lithium a lot and we'll need it more, which see in the presentation. And I was wondering if there are any possible alternatives to lithium in the future.
There are a number of alternatives, and I think at the moment everybody is thinking that lithium-ion batteries are going to be the way forward for everything, like for grid-scale storage related to renewable energy and things like this. But there's things like sodium batteries which are being pushed. There's solid-state technology, solid-state batteries. You name it, there are alternatives. Lithium-ion batteries are great for transport because they're light. I mean, I know a Tesla or another electric vehicle, they're really heavy, but if you put like lead-acid batteries or something else in there to generate the same amount of energy, you know, you wouldn't be able to move the thing. So lithium-ion batteries are great for transport, they're great for certain technologies we're using now like smartphones and so on, but they're not going to be the be-all and end-all. And then the other thing we should think about is not just the recycling side of things, but reuse. So if you, for example, take lithium-ion batteries out of a Tesla and put them on a solar power farm, then that could actually extend their life, which wouldn't be great for the recycling side of things, but would be great for actually creating grid-scale storage. Because the difference in use, the difference in recharge rates means that you can effectively prolong the use of those lithium-ion batteries. But there are alternatives, and we don't know when those alternatives are going to come on stream. We don't know what effect that's going to have on the lithium sector. So the predictions I showed up there are subject to huge uncertainty. Those demands could be far higher. They could be lower because we actually have alternative technologies coming on stream that we don't know about yet. And I'll give one example. There's a lithium deposit in northern Nevada called Thacker Pass, which some of you might have heard of. A really big lithium volcanic clay system, one of the biggest lithium deposits in the world. It was discovered in the 1970s by Chevron, who were looking for uranium. They found a really big lithium deposit. In the 1970s, nobody cared about lithium, so it sat there for 30 years before anybody thought about maybe lithium demand is such that we might be able to do something with this thing we found 30 years ago. So that's one example where 20 or 30 years ago, nobody was talking about lithium because we didn't know that lithium-ion batteries would be such a big thing.
I wanted also to ask that we should also focus maybe on promoting the lowering of consumption so that we don't have to fly more in the future.
So certainly becoming more economical is a crucial thing, and it's happening already because we're seeing actually not just a reduction in consumption, but technological advances actually reducing the mineral and metal demand for, say, a megawatt of energy generation capacity. I think there are good arguments for reducing consumption, but also I think that one argument will not work everywhere. I think if you told people in Europe that reducing consumption is a great idea, then a lot of people in Europe would agree and maybe go along with you. If you told a whole lot of people in the US that reducing consumption would be a good idea, they would go out and buy a gas-guzzling SUV and swear at you. So I think, and equally, we can advocate for reducing our own consumption, but we can't tell other people to reduce consumption who, for example, want the same standard of living that we want. So there's a whole lot of people across the world that don't have the standard of living we're used to in Europe, we're used to in North America. If we start to say to them before they've reached that standard, you need to reduce consumption, then some people might call that sort of neo-colonialistic arguments against actually developing in other parts of the world that we've exploited in the past.
So thanks for your presentation. My question is, from your point of view, what will happen in the next, let's say, 5 to 10 years about recycling lithium batteries, especially I'm talking about car industry?
I think it's going to increase. I mean, we're already seeing increases right now, but we just need to make sure that the capacity is in place for that increase. You can't just wait till the batteries are available to actually start that recycling process, because if you do that, it's going to be too late and we're going to lose a whole load of lithium, which might be great for the minerals industry and those of us looking for lithium, but the fact is it's not good from a social, environmental, or any other viewpoint. So I think we will see positive moves. We need to see positive moves, because that statistic that I mentioned, that the number of electric vehicles that were produced in 2024 is something like equal to all of the vehicles produced before 2020. So we're seeing this ramp up in demand already, and we just need to make sure we're ready when all those cars start to come to end of life.
Let's say at the end it should be recycled, and for that means the factory using hydrocarbons. So if that means more demand for hydrocarbons.
Well, you don't need hydrocarbons, you can run it on electricity, and that's what we're doing. So there's a company called, I'm not plugging them, but the company I mentioned that's doing the lithium-ion battery recycling in Nevada is not using hydrocarbons. It's essentially using renewable energy, because we have a lot of solar potential, we have a lot of wind potential, and we have things like hydropower and things like this. So I think if we're going to move towards electrifying everything, we need to make sure that electrification is using renewable energy, and that's, there's a huge potential for all sorts of renewable energy: geothermal, not oil and gas, geothermal, solar, wind. There's probably a role for nuclear in all of this, depending on which country you're talking about. It is. If I had all the answers, I wouldn't be standing here. I'd be sitting in a tropical island drinking something out of a coconut. So I've used that line before. I like that line.
Hi, thanks for the presentation. I wanted to ask about the student enrollment. You showed us the chart there, and I saw sort of peak in student enrollment in, I don't know, 2013 or so. And do you know why was that? Was that some administrative artifact, or is it really that at that time there was more enrollment of students in geoscience?
I think there was more enrollment in geosciences. Why that was the case, I don't know. I mean, I haven't delved into those data that much. I know there's various groups in Europe, in the US or North America that have looked into those data. And we do see peaks and troughs in enrollment, and we see peaks and troughs in student enrollment full stop. But I think that was actually a proportional peak, as in there was more geoscientists per total student population number than there is now, for sure. And I don't know why. This might be a case of understanding why that time was successful and what else was happening in terms of making people realize that the geosciences is a viable, career option.
Okay, thank you.
I'm just going to keep on talking till the coffee break finishes, aren't I?
So in regard to that last question, I was thinking it had to do with Obama's fracking and hydrocarbon policy. That was when the U.S. became the largest oil producer. So maybe, but I don't know. My question though,
I mean, that might explain the U.S., but it wouldn't explain the other enrollments we see in other countries. So.
Yeah. So my question is not about lithium or recycling. I was wondering actually about the permitting process, because I've heard that opening a new mine requires decades of permitting, essentially, where there's so much red tape involved that eventually it just becomes not even profitable to open the mine. So if you could comment on that.
So it does take quite a while to open a new mine, but some of the statistics out there are misleading. So a lot of the statistics around permitting focus on date of discovery and then date of production. If we took Thacker Pass, that lithium deposit, that was discovered in 1972, and it's still not open. But that's nothing to do with permitting, and yet it's incorporated into some of those statistics. So there's that statistical bias, which is useful if you're arguing that permitting is a challenge, but I think that hides some of the actual reality. I think there's certain cases where the minerals industry don't start generating baseline data. A lot of environmental impact assessments require large-scale baseline data acquisition, environmental data and so on to try and work out what impacts might be. And if you don't start that process of maybe 2 years of data acquisition early enough, then that's going to delay everything because you don't have the data required for the permitting. And we need to do this permitting in a responsible way. The other thing I'll say is that there are certain places where permitting is really efficient and really fast, and Nevada is one of them. We are the #1 mining jurisdiction in the world according to the Fraser Institute's annual survey, and we do permitting pretty quick. So anything from 12 to 36 months for permitting of new mines and mine extensions. And that's not because we're cutting corners, that's under the previous administration as well as the current administration. It's the fact that we do things pretty well. We have people who are experienced in permitting, the permitting process. And up until recently, we had actually a whole load of people with the Bureau of Land Management on the federal side who were devoted to permitting in the state. Now, the current administration has reduced that number of people, and so we've lost a whole load of really skilled people who could deal with permitting. So we're seeing permitting slow down at a time when the federal government wanted to speed up. And that's because basically the federal government has made a decision to get rid of people. So there's nuances to all of this. I think that if you go too far and actually start to essentially remove red tape or reduce the rigor of permitting, we're in danger of kind of losing or moving negatively towards some of these things. If you don't consider the environmental impact, if you don't consider the social impact during the permitting process, then what you do is you end up making bad decisions, allowing poor mining projects to go ahead, which, if something goes wrong in the minerals industry, everybody's affected because everybody finds out about it, and that means that we all get blamed the same, even though you might have the best mining operation out there. I think that's sort of answered your question, but it's complex.
Last question, so anything to Thanks a lot. Actually, I have a question. Do you think that the government and the people who decide what kind of economic efforts we have to do are actually ready to work on the stuff you presented? Because basically, the shortages in mining industry, etc., I would say, to much extent relate to outsourcing of cheap and dirty jobs to other parts of the world. The problem is if we want to make more people working in this kind of stuff, we need to make it some kind of sexy. And to do that, we not only need to provide salary, but to good salary for people here to work for it. But if we also want to still have some economic independence, we need also to localize those facilities here in Europe, in America. So the question is, do you believe we already have reached the economic point that people actually understand the needs of this kind of people?
I think that I think we're moving in that direction, but I think that policymakers in a number of cases need to understand the reality of the minerals industry because, taking the US as an example, the US will never become entirely self-sufficient in all the commodities it needs, and it shouldn't, because there's no point why would we develop large-scale nickel mines that are really uneconomic because of the mineralization we have when we can essentially friend-shore them from Canada if we have a good relationship with Canada because they have Sudbury, they have Raglan, they have a number of major nickel mines and so on. So I think there's in all of this, there's a role for all of us wherever we can to educate policymakers because the policy they dictate essentially moves us in a positive direction or moves us in a negative direction. We need to think about whole of supply chain approaches. We need to realize that if you open a copper mine in Arizona, unless you've got a smelter with capacity, that copper is not going to be smelted in the US, so there's a big chunk of that supply chain that's going to move somewhere else. I think that there's a lot of conversations going on about this, but I think that there's an awful lot of people out there who think they know a lot, but actually they don't, and they're probably making poor decisions as a result. So that means it's beholden on all of us in this room to try and talk to people where we get the opportunity to educate them about not just the importance of the minerals industry, but the reliance of things like supply chains and so on. I think I've sort of answered your question. If not, then we can chat over coffee or something. It's a long and complex thing to think about.